Hello everyone, in this video we will explore a bit further some inputs configuration by showing you how to change the reporting currency when pricing a portfolio. And that comes particularly handy when the currency of the trades in your portfolio is different from the currency in which you want to report your accounting. In other words, the currency in which your trade is collateralized. To do so, and to make it easier to understand the incrementation of data needed to configure this, we will be using the data from the equity option example video as a base and expand from there. Let me remind you very briefly what the initial configuration looked like. We wanted to perform an NPV pricing on a European equity option with implied volatility on the Euro Stoxx 50, so with a euro denomination. And the reporting currency was also euro, so no FX conversion needed. In terms of inputs, we only needed the discounting curve in euro and the equity curve and volatility of the Euro Stoxx 50. The euro EONIA was used as the euro discounting curve, and this is what it looks like in terms of data to configure and provide in ORE. Since the 1st of October 2019, it is calculated with reference to the euro ester plus a spread of 8.5 pips, which means we need to first build the ester curve as a combination of one deposit quote and multiple OIS quotes. And once built, we need a zero spread of 8.5 pips. You will also notice that each of these particular instruments have their own set of convention, here, here, and here. Then we had the set of configuration to build the equity curve, which was done with the spot and a series of equity option data, plus the euro EONIA as a forecasting curve, which is obviously a reality build. And we had the equity volatility built using the same equity options used for the equity curve. Now let's actually look at how to change the reporting currency. To make it clear what needs to change compared to the initial configuration, here on the left, I'll show side by side the differences in the input files using the compare tool of Notepad++, which is quite a useful little tool and very easy to use once you've downloaded it. To download it, it's very easy. You go to plugin admins, you search for compare, here it's already installed, and you just have to click next and install it. Then in plugin, compare, and voila. And in the master file, the RE.xml file, you can see that the only differences here is obviously the base currency going from euro to USD. Changing the collateralization currency means changing the currency in which the cash flows are discounted. So in our case, the first thing to do was to add the USD discounting curve in the today's market file. And this is the first new input to add among a few. Now, it is worth noting at that point that this is one example of curve that can be used, and there's multiple ways to discount in USD. But let's take a look in details what the configuration for this USD and Euro looks like. Defining it in the market today's file means we need to also define it in the curve config file, and we will find it in the yield curve section, and it is a curve of type cross currency. Now, when the node name is cross currency, the type node can have the following values: FX forward, cross-currency basis swap, cross-currency fixed float swap. Here we've used first some FX forward instrument quotes with maturity almost up to 2 years. The discount curve node holds the curve ID of the curve used to discount cash flows in the other currency, so not the USD here. And here we use the Euro EONIA, which we already built. And we also use the spot rate node, which holds the ID of the spot FX quote for the currency pair. So this will be also found in the market data file. The second type of instrument used is cross-currency basis swaps. And we have here quotes from 2 years to up to 30 years. Same as for FX forwards, we have the Euro discount curve. We have the same spot rate, but we also have a domestic projection curve, the USD LIBOR 3 months, and we have a foreign projection curve, the Euro Euribor 3 months. Now, if we look at this a little bit more visually, this is what it looks like in terms of configuration for adding the USD and euro discounting curve. We first have the FX spot. As part of the FX forward, we have FX forward quotes. And we also have some cross-currency basis quotes and domestic and foreign projection quotes. On top of it, we have the two conventions. Now, for the domestic and foreign projection curve, we haven't built these two curves, so this will need to be built as well. Just as a side note, you can add comments in XMLs to easily identify each curve or even each node. And this gets useful very quickly because this type of files get crowded very fast. But you can also add nodes attributes actually, as long as they are not used by RE directly. Now, looking at the USD LIBOR 3 months curve, it is built using a single quote deposit, a series of FRAs from 1 month to 9 months, and a series of swaps from 2 years to 50 years. And it's using a projection curve, which is calling itself. It is also using a discount curve called USD Fed Funds. And as you would have noticed, this curve has not been built yet. So this leads us to the next curve to build. Now this one is built using USD deposits as well. It is using overnight index swaps from 2 week to 1 year, and is also using average OIS. Now, this average OIS are swaps where a fixed rate is swapped against a daily average overnight index plus a spread. And that's why the quotes for average OIS instruments are actually not quotes, but composite quotes, which consist of a vanilla IRS quote on the red quote and a OIS LIBOR basis swap spread, the spread quote. And with this, we are able to build everything USD related, but we still need to build the Euro Euribor 3 months. To build this curve, we are going to use Euro deposits, some FRAs from 1 month to 18 months with a projection curve calling itself. And we are going to use tenor basis to swaps type of quotes. The quotes in this type of nodes are actually spreads between two curves from the same index, but of different tenors. Here we have the curve projecting the floating rates on the short tenor index, the 3 months, and this node holds the curve ID of a curve for projecting the floating rates on the long tenor index, the 6 months, which means we need to build yet another curve, the last one, I promise. And this curve is quite standard with deposits, series of FRAs, and a series of swaps. And with this, with all this curve, we are able to actually discount in USD the whole portfolio. And looking at this graph, it means we need to add 1, 2, 3, 4, 5 curves and all the market data that it involves, plus also all the convention in green here, and market data in yellow, in order to be able to discount in USD. Looking at the today's market file, so we had initially added just the USD discount curve, but that means we also need to add the 4 index running curves and also, of course, the Euro USD FX spots. And looking at the convention file, we need to add all these new conventions such as USD deposit, some OIS, USD funds OIS, average OIS, FX, cross-currency basis, some FRAs as well, swaps and tenor basis, 2 swaps. I'll let you discover all of them. And finally, looking at the market data file, we can see that we've added around 200 new market data points. Regarding the FX and the pricing engine files, those haven't changed. And finally, after running the calculation, you can see that in the NPV file, the difference is only on 3 different columns. The best currency change from Euro to USD, and the NPV and the notional base has been adjusted as well. And this ends this tutorial. Thank you for watching. I hope that was useful. See you next time.